So we already installed the Hadoop, right? So Hadoop, once we install, we get HDFS and MapReduce. Okay. So HDFS is a storage component, and MapReduce is the processing component. Okay. So HDFS has the further two more component, name node and data node. Okay. So name node is containing the metadata, data about data. So it's containing the metadata, which is data about data nodes. Okay. And data node is containing the actual data. So it's a master slave architecture. So name node is master and data node is slave. And name node is sending the heartbeat signal to every data node to check whether the data node is alive. Okay. And it is getting back the acknowledgement signal, right, from the data node. So if data node is down, so the name node will assign another data node for the processing. Okay. So data, actual data. Okay. So when we will talk about, when we say, what is a Hadoop architecture? So Hadoop architecture, SDFS and MapReduce architecture, we have to explain. And when we talk about the SDFS architecture, so name node and data node, we'll talk about, because name node, data node, and secondary name node. So secondary name node is a backup node. It's a backup of name node, and it is syncing the metadata from the name node to secondary name node. Okay, so any point of time, if name node down, right? Because data node is down, so who is taking care? Name node is taking care, because name node is master. And name node has all the information about the data nodes. But when the name node itself is down, so secondary name node is a backup of name node, which is syncing, is backup, and it is syncing metadata. Okay, syncing metadata. But there was some issue with the secondary name node because it takes 30-minute time to sync. It is taking 30-minute delay, right, in syncing. So it's so you will not get the recent request, right? Whenever some metadata is stored, right? So that metadata will not be available. Okay. So last 30-minute metadata will not be available when you are using the secondary name node as a name node. Okay. So in that scenario, like in Hadoop 2.x and 3.x, so Hadoop 2.x and 3.x standby name node concept is there. So 2.x and 3.x. So there is a standby name node. So standby name node, or we can say passive name node. Passive name node. This passive name node is basically become active when active name node is down. So one is active, one is passive, and both are having the same configuration because both are the same configuration machine. And you know, right, name node machine configuration should be high rather than data nodes, because name node is not containing the data, actual data, but it is containing metadata. And metadata is a very crucial, right? Because if name node is down, right, so we have passive name node, but we want to make it higher configuration in terms of memory, in terms of days, like it's a kind of server machine, right? Name node, okay? So data node could be a cheap hardware, right? I can use the commodity hardwares, right? Okay. So Hadoop says we are providing the high availability. If the data node down, so name node will have the backup of the data node. Replicas are there, right? So one data node has replica in the another data node, right? So there the replication factor is there 3. So replication factor 3, so means it's a 3 copies. Okay. So 3 copies of the data on the 3 copies of data means 3 block of copy, 3 blocks. So 3 different block of copies in 3 different machine. 3 different machine, so that 3 different machine, so that if one data node is down, so other data node will be available. Other data node, the actual data will be available. Okay. Okay. So that is the failure of the data node, right? So how the data node failure is like recover. because of the replication factor. But name node backup, right? If name node goes down, so name node is a single point of failure. If no name node is down, means entire cluster is down. So for name node backup, right? Name node backup is like standby name node in the Hadoop 2.x and 3.x. So standby name node is called passive name node, and will become active when active name node down, and this active like passive name node will active within a minute. So within 1 minute time, it will become active. So only 1 minute delay will be there. So only 1 minute delay, right? So that is not a measure, right? Like 1 minute delay is not a measure. Okay. And how this syncing process is done, there is a journal node is there. Okay, so if anybody ask you like how the syncing process is done, there is a in between journal node is there, which is in between of active and passive name node. So this way, the journal node is basically syncing the metadata. So name node is containing the metadata. So syncing is the active name node metadata to the passive name node metadata, between the active and passive name node metadata. So this process is there. Okay. So this is the architecture thing, right? Hadoop architecture, right? So high level architecture, but this is the architecture in the storage one. Okay. When we talk about the processing, right? We have a resource manager, right? So in Hadoop 1.x, we have job tracker and task tracker, but 2.x and 3.x, Hadoop 2.x and 3.x, we have resource manager and node manager. Source manager and node manager. So resource manager is master and node manager is a slave. And resource manager is allocating tasks to node manager. Okay. And node manager is doing actual tasks. Node manager is doing actual tasks on data node machine. So every one data node, there is one node manager is there. So node manager is allocating tasks. Node manager is doing actual tasks on the data node machine. Okay, one node manager. Okay, on the data node machine. Okay, which is doing the task. So same thing is here. The heartbeat mechanism, like resource manager. Resource manager is allocating tasks. Okay, not only allocating tasks, it is doing managing the resources. So resources means like CPU, memory, hard disk, right? CPU, memory, hard disk. Okay, so these are the resources need to be provided to the. These resources need to be provided to the job, right? So whatever jobs are running, we are providing the resources to the jobs. Okay, so these are the resources are called containers. The term is their containers. So this resources are called containers. So if I say like in the this is the yarn architecture basically. The yarn architecture is basically there is a resource manager is there, and there is a one component called node manager is there. Okay, and there is application manager, resource manager, application manager, and node manager. So in between of the resource manager and node manager, there is the application manager. And this application manager is controlling each and every data nodes node manager. Okay. And node manager, there is a one application master is there. Okay? And this application master role is to provide containers. Containers means here CPU, memory, and disk. Okay. CPU, memory, and disk to the node manager. Okay. So that particular node manager on the same machine, it is providing these resources. So who is allocating the resources? Primarily this application master. Okay, application master is residing on the same node manager machine. Okay, so what are the resources? Resources are called containers. So this is like a flow, right? Whenever user is requesting or run a job, right? User is requesting to run a job, So this request will go to, first it will go to the name node, right? Name node it is a task, right? It is a kind of computation task, right? So resource manager will allocate, resource manager will be finding like node manager on those particular data node machine, node managers on those data node machines where data is available. Okay. So in the cluster, there are so many data nodes are there, but only specific data nodes, your node manager is performing the task. Okay, because this information who is giving? Name node is giving the information. Okay, so name node is providing information about data node to resource manager, and resource manager will be finding the node manager on those node manager on the data node machines where the data is available, allocating task to node manager. It is little like confusing here, but just think about it here. Like in this processing architecture is a resource manager, node manager, okay, application manager, resource manager, application manager, node manager. And node manager is using in the same machine, application master is there. Every machine is having one node manager and application master, and the particular resources are there because every machine has CPU, memory, and disk. So how much percentage of the CPU, memory, disk, who will decide? Application master will decide, right? Okay, as per the job requirement, okay, the task requirement. So the one task is given to one task is given to the node manager. So resource manager is allocating the task. So resource manager is dividing the job. Resource manager is dividing job into tasks, and these tasks are given. These tasks are given to node managers. Okay. So different data nodes machine. So this node managers will be performing on data node machines. Okay. So it will depend on how much data size you are processing, right? So suppose your data is very small, right? It's just processing on a one data node. So one task is like allocated to the node manager on that particular data node machine. Okay. Okay. So this is the yarn 2.x architecture, 2.x, 3.x architecture. So yarn architecture, which is providing. So one concept in the Hadoop 2.x is the high availability concept in 2.x and 3.x Hadoop version, 2.x and 3.x. This active name node and passive name node. Okay. So this active passive name node concept, passive name node concept is there. Passive name node. Okay. So this is the high availability concept, and the second one is for processing, right? This allocation of the jobs and tasks, right? So that is called yarn architecture. So yarn architecture is related to like resource manager allocating the task, and it is managing the queues as well, right? Resource manager, suppose multiple jobs are coming, so resource manager will decide which job will be run first, there are different types of queues are there, like FIFO is a one queue, first in first out. Capacity scheduler is there, capacity scheduler. So these are the schedulers are there. FIFO is the first thing. So which job will come first? That will be process the data first. Capacity, and one is a pool also there. Okay. So the different types of these schedulers activities is also done by the resource manager. So in 2.x and 3.x, resource manager is not only managing the allocation of the task to the node manager, it is performing the the management of the resources as well. Okay. Is it clear so far, this one, architecture things? Okay. So,
Question.
mm,
Sorry. So you mentioned the replicas and the passive node, right?
mm,
So do they both do the same thing, like, just take a copy of a active node, or does the passive node do the replica job?
passive is like basically syncing with from the active name node. Okay. Both have the same configuration in terms of disk, memory, and CPUs. Okay. Both are the same configuration type. Okay. Just we are adding a one more extra master, right, as a passive name node, but it is not active at the moment. Okay. It will active only when the active name node is down. Okay. But it will be there in the system, and parallelly whatever the metadata is accumulating, right, in the name node machine, the same metadata will be copied over there in the passive. Suppose one point of time your active is down, right? Your active is down. Okay. So your passive should have the similar metadata, right? Otherwise, it will be not handling your request, right? So active passive will be there both at the same time. But when the passive will become active, passive will be active when active will be down. Okay. So configuration wise, both are same and parallelly syncing with the help of journal node. The journal node is the node which is making it syncing of this active passive name node metadata. Okay. But both are same configuration, right? It's like a machine. Whenever we are talking about like data node, all these are the separate machines. Suppose you are installing your Ubuntu and VirtualBox you install everything in your one machine. So it means the same machine you have name node, data node, everything is in on the same machine. All 5 services are running on the same machine. Secondary name node, okay.
Yep, I
And
understood that.
you have data node, you have a resource manager, okay, resource manager and node manager. All are the same machine. But if you are using cluster, right? So cluster, suppose you have a 10 node cluster. So in this 10 node cluster, what you will do, one machine you will have, okay, active name node, you can keep it. One machine you have a passive name node services there. One machine you have like a resource manager is there, and other all machines are the data node and node manager together. Okay, so I can say 3 machines you allocated, one for active. Okay, because if you don't keep it on the separate machine, so what will be the use of the backup, right? Because if, right, so that is the reason these all machines should be separate. Okay, passive. Okay, and the high availability things will be there also, right? Because here the same machine, everything is there. If machine is down means everything is down, you can't access anything, right? But here is, if this one machine active name node is down, right, this active name node is down. Okay, this active name node is down, so passive name node will become active. So there is a backup of this active is this passive, and one is resource manager. You have one machine. Okay, so resource manager is basically the interacting with the all data nodes and is the like a node manager, right? So node manager is basically, so node manager and node managers are there on the data node machine. Okay, so node managers and data nodes will be together in each and every machine. So I can say 7 data nodes will be there, and other 3 are the active, passive, and one resource manager.
Okay, thank you.
Okay. So this kind of configuration we can create, okay, depending on the machines, right? If I say I have 100 nodes cluster is there, so in that case I will not have one active, one passive. I can make it like a segment, right? I say like 2 active, 2 passive, right? Okay, so because I need to manage 50 nodes by 1 active, 1 passive, and other 50 node 1 active, 1 passive. Because if I give the more burden on one node, name node, right? So that will be your processing will be hampered, right? Okay. So in that scenario, if the cluster is big, so we can increase the number of active, passive name node. We can increase, right? We can increase. Sometimes one active name node, but we have 4 passive, right? So like for more high availability, right? Suppose, right, this passive also can become down, right, at any point, right? So if this active is not becoming like this passive, right, like once it is down, so how soon like it can become active again? Okay, so for that moment, right, so we have to like keep the backup, right? So two passive name node we can keep it. Okay, so it is the configuration, right? Depend on configuration how we can make it in the big cluster, right? For the small cluster, right, like 5, 6 node or 10 node cluster, so one active, one passive is enough.
So high availability depends on the how much
Cluster size,
you give. Yeah,
like
okay. Cluster size for passive name node.
yes, if small is there, like active one, passive is enough, right? But if big cluster is there, right, so you can have multiple active, multiple passive, right? You can keep it. Like you can say these many, because how name node will identify these are the data nodes are related to this particular active name, because the IP, the configuration file is there, one host file. So all the data nodes machines IPs have in this active name node. So it means these particular data nodes have any issues, so this particular active name node will handle. Okay, so that way they are controlling, right, in the cluster. Okay, yeah. So see, master has to keep the information about the slave, right? Because slave knows, right, my information at the master, right? If any point of time any slave is down, so master will take care of that. So slave doesn't need to think about it. Okay, because data node, any point of time it goes down, right? Any failure can happen, like machine can be crashed. Okay, okay, so when we are going to start the Hadoop, right? So Hadoop commands we have to know, right? So they are the Hadoop, two types of commands are there: Hadoop developer command and Hadoop admin command. Developer and admin command. Okay, so mostly we are working as a developer command, but some of the basic admin commands we know, right? Like some like we want to see the status of the cluster, or we want to use safe mode. One safe mode is an admin command. So I will show that how to use the safe mode. So sometimes your you want to know the status of your safe. So generally when you start your Hadoop service, so immediately it comes in the safe mode. And have you seen sometime when you start your Hadoop service and immediately if you do any like a directory creation or any manipulation you are doing, it is not allowing. So it takes, because this right, in the there is a fs image and one is a edit log file is there. Okay, so fs image is the memory copy of metadata, okay, and disk copy is called, and edit log is a disk copy. So whenever your name node machine down, so generally when you are making Ubuntu means shut down, right? It means your Hadoop is down, right? Because you are doing, because you don't need a high availability, right? Like your system should be running and anybody access your system, right? Okay, because you are doing development thing. But in practically is happening in the cluster like this, right? Because memory copy is maintained in the metadata is a fs image file. Okay, and whenever your system is down, right, your name node is down, so this fs image copy will be gone, because this is a memory copy, and memory copy, right, it's volatile, right? So it will be gone, but edit log will be remain always there. So this is a disk copy. Okay, so whenever your name node machine restart, okay, so it will create again the fs image copy from the edit log file. Okay, so immediately this transition it does, right? So when Hadoop starts, it starts and then it create a create new copy of fs image. Okay, and that moment you can't do any operation on the Hadoop, like at least for 30 seconds you can't do any operation. So whenever you are trying, immediately start the Hadoop service and you try like Hadoop fs mkdir command. Okay, if you run this command, so it will give you the error, your 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 name node is in the safe mode. So safe mode, you can't do any command. So suppose you are trying to create any directory, it will give the error. Okay. So error will be your name node is in the safe mode. Your name node is in safe mode. So we have to, if you want to do any operation, just come out from the safe mode. So there is a command sdfs root tfs admin safe mode leave. So you just safe mode leave command you do. So it will come out from your safe mode and you can do. Okay. But by default, it will take 30 seconds to perform. Okay. To come out from the safe mode. Okay. So this is the admin command I will tell, but there are the developer commands. The developer command is manipulation of the data on the Hadoop file system. Like you are creating a directory, okay, copying a file in the local to Hadoop file system, creating directory in the Hadoop file system, copying file, renaming file, all whatever operations you do manually, right? The command line, right? So those in the general file system you do, right? In the Linux, Unix file system. Same we can do in the Hadoop file system. But we have to use for every command, we have to use Hadoop fs prefix. Suppose you want to do mkdir, so minus mkdir, and you tell about the directory. You say test directory I want to create. Suppose you want to cat a file, Hadoop fs minus cat, and say the test slash some abc.txt file like you want to see. And one more thing is a Hadoop is a virtual file system. It's not, you cannot go inside the file system. It's a virtual. So you have to always give the entire path. Suppose your directory path is /test/test1/test2. So entire path till the file you have to give. Then only you can see the content of the file in the Hadoop file system. So suppose abc.txt there, you can't give abc.txt. So if you give only abc.txt, it will understand this file is in the Hadoop base directory. But this file is actually is in the test directory. So you give the complete path test/abc.txt. Okay, suppose another one more directory is there, test1. If the file is inside the test1, so you give complete path test/test1/abc.txt. Otherwise, it will say file not found. Okay. So if something is missing in your path, okay, if your path is not complete, so it will give you the error, the file or directory not found. Okay. So we already installed Hadoop, right? So I start the Hadoop command line. Okay. So so there are the 30, 40 commands are there, 30 commands are there. We can see the list of all Hadoop commands. There are the all Hadoop commands we can see. There's a developer page, we can see all the Hadoop commands. So if we go to the official page there, these are the all commands. Okay. So these are the all commands are there, like append to file, cat command, chmod. So you will see these are the command mostly Linux command, right? Like head command, tail command, mkdir command, ls command, remove command, rm directory command. RMR is like file or directory, everything you want to delete. So RMR you use recursive, and mb command, copy command. Okay, so these all command are there. Touch command is to create a new file, right? Touch command is there. So these are the commands, the developer commands. So sometimes your data is in the local file system and you want to write the data into Hadoop file system. So for any analytics you want to do, your data should be there in the Hadoop file system. Because if your data is not in the Hadoop file system, you can't process your data, right? So if you want to run a MapReduce job, or you want to run a Hive queries or a scoop import, so your data should be Hadoop file system. Okay. So Hadoop file system, we have to copy the data. So we will use this copy from local command, from local file system to Hadoop file system. So this command, like some parameters are there. If we go to one command like cp, the cp command is a two path are there. One is a source path, one is a target path. But CP, in the case of CP, you have both paths should be Hadoop path. But if you see copy from local, the copy from local is one is a source path and one is a target, but source path is a local path. Here, the copy from local is the first path, same like a put. Okay, so put and copy from local, there is no difference. So put, either you can use put or you can use copy from local. So put, just you go put, so local file path and Hadoop file path. Because we are copying from local to Hadoop, so we use the put command, okay, or copy from local. These command practice, you can do one by one command, you can take it and then you can do practice. So these are the fundamental command, and everybody should have practice of this command, right? Because these are the day-to-day life command. Like whenever we are doing any manipulation. So if I say I have a file here in my local, okay, I am creating a directory. Okay, so here is nothing is there, no file. Okay, if I do LL, okay, so nothing is there. I'm just creating a one file here, cat and test.txt. So I'm just writing some data, the file, control D. Now if I do ls here, now I will see the test.txt. Okay. So if I want to create, right now in my Hadoop directory, I show you Hadoop fs minus ls slash. So this slash means Hadoop root directory, Hadoop file system root directory. So I got the error right connection request. So it means I'm directly trying to run any Hadoop command, but I have not started my Hadoop service, right? So I have to start all.instance. So first I have to start the Hadoop service. So when you are getting this error means you are not started the Hadoop service. So you will get the connection request. Okay, so I'm started. Like now I can check with the JPS. You already know the 5 services are running. Now I do Hadoop fs minus ls slash. So now I'm going to check my. So these are the directories already created, right? Because I'm already using the Hadoop file system. So these are already there. So I want to create a new directory. This is Hadoop fs minus ls slash. So particular directory I want to see. Okay, I want to see this particular directory data. So what command I will write? Hadoop fs minus ls and then give that particular directory. If you know in the directory having other further directory. So if you see here, you can identify this is a directory of file. So you can see hyphen, hyphen, hyphen is there. It means it's a file. All these are the 3 files are there. Okay. But suppose I say this directory I want to see. So there will be further directories are there. Hadoop fs minus ls. So I can see here 2 directories and 1 file is there. 2 files are there. So 2 files, 2 directories. And this directory again I want to see. So I will say slash info. Okay. So I can go. So here is nothing is there. This directory is empty. Info directory. If I say instead of info, I say new one two. So in the new one two directory, that is also empty. So these 2 directories don't have any files or directories. Okay. So I want to create a directory, my new directory I want to create, and some this directory I want to create. So I created a directory. Now I want to see whether this directory is created or not. And this is a warning message. So this is just a warning message. So nothing error. Abhi right now, I just created a directory. Now if I do ls slash testing 123, so I will see, okay, I have to give the root path so I can see the testing. So if I say root, so I can see testing 123, you can see. So here the testing 123 is created today. Today is the 5th of December 19. This is the 2118, right? 918 time. So this particular directory is created. So mkdir is creating a directory. Now I have a file here, this test.txt. I want to copy this file in this testing 123 directory. Hadoop fs minus pro, and I give the file name. I told you the source path we have to give. So file is itself in the same directory. I don't need to give the complete path, right? Otherwise, if I see what is the path of this file, pwd, so I can see present working directory. I can see this is the path of my file, okay? Because this is my user directory, the user which I have installed. So home user is my home admin is my user directory, and this directory is where my file is present. But I don't need to give the complete path because I'm in the same location. So I will just use the file name, and I want to copy into in the testing 123 directory. So I want to copy the file. This is copying the file into testing 123. So how to see the file? Hadoop fs ls and testing 123. Now I'm giving testing 123 because file inside the testing 123. So I have to give the path till testing 123. So you can see the same file which was here. What is the size of the file here? 18 KB. Okay, the same size is here, right? So I want to match the content. Okay, first I check the local content, cat command. So simple cat command, I can see the content. And when I want to see the content in the Hadoop, I will do this. I can see the content of the file. The same content you can see the here. Okay. So far we see how to create a directory, how to copy a file in the Hadoop directory, and how to see the content of the file. Okay. So if I want to see what are the Hadoop command are there, just do Hadoop fs. So you will see same list of command which I shown on the website. Same commands are here. Okay. So append to file. This is copying the two local file to the one target file. Okay. Okay. We come to this one, but I want to show. So copy from local and put command both are same. Okay. So either use copy from local or put command. Okay. Suppose I do same Hadoop fs minus copy from local. Okay. And my test.txt, I want to write testing 123. So what will happen now? Because copy from local also copying the same file, right? But this time it will give the error because file is already exist over there, right? With the same name. So one option is you can choose the different file name. Like you say test1.txt. So this is the one option. Just this is the same Linux things, right? Okay. So when you are copying the file, right, you don't want to override it. Okay, you want to create the same file content with the different name. So that is the one option. But if you want to override deliberately, like you say testing 123, you want to override it, but you will get the error because the same file is there. But Hadoop has given the option if you use -x option. It's overridden, right? So suppose your content is changed, your local file like test.txt content is changed in your Ubuntu, and you want to still want to override in your Hadoop file system copy of the same file. You want to you want to override, so you can use -f. So -f means forcefully you want to override the control. Okay. So this is copy from local you can do. Okay, so copy from local and put both are same command, and both we can use -f option. Okay, minus put, minus F you can use, or minus copy from local. The reverse command of the copy from local is a get command and copy to local. So put is a reverse command is a get command, and copy from local reverse command is a copy to local. So if I have a file in my Hadoop file system, so I say get command, and I have a file in my testing123 slash test.txt. This is the file in my Hadoop file system, and I want to get in my local. So local here, even if you don't give the anything, it is fine. Or if you give dot, dot is representing the current directory. Okay. Or you can give the some local path. Okay. So you have to give the local path means Unix path, Ubuntu path. Okay. Because here is source is Hadoop path and target is the Unix path. And the other command is a put command is a first is a Hadoop path and target is a Hadoop source path, the source path, local path, and target is a Hadoop path in case of put command. So when you do this dot, right? So now again same error you will get file like this because the file name is same. So if you want to change the file name, you can change the file test1.txt name you want to get the file. So then it will not be give the problem. So you are taking a new copy. If you say cat command and test1.txt, it is getting the file from Hadoop to local. Okay. So either you don't pass anything, you don't give anything, that is also fine. That is understood the current directory. So same test.txt is coming. So what is the option here? Minus. So minus F, it will understand forcefully. So this minus F you can use either port, copy from local, copy to local. So copy to local is the same version of the get. So either you can use get or copy to local. Copy to, but remember it, whatever the conjugative word is there, it's a camel case, like you have copy, then to T capital and local, L capital. Okay. The copy to local and this one is the same command because minus F I'm using, so it is overriding. Okay, so this is all command here. If I see here, how do that first? Okay, now I tell this command append to file. Okay, so I'll make a list, right, so that you can follow the same. So first I tried hadoop fs minus ls slash command, hadoop fs minus mkdir from directory I created. I'm just taking the same name, and then hadoop fs minus put, or you can use slash minus copy from local, and then you give the local path, like suppose test.txt is there in my local, and I want to copy in the test command. And another command I tried with minus F option. So same command, if you run the second time, you will get the error because first time it will not give because first time it is not copied. The second time, if you test, then you apply minus F. The same two commands you will use with the get or. So here you will use get command or copy to local. Okay, copy to local, and here will be first come Hadoop path. Okay, so testing123 slash test.txt. This is your Hadoop path, and local you can give either dot or without any dot, both are fine. Again, you want to test with the minus F option. So same thing, you will try this either get or copy to local, you can use with minus F. And another command is here you can use dot or without dot, even this is also fine because it is understood like you are bringing the file from the Hadoop file system to local, right, current directory. Okay. And another one is Hadoop fs minus get command. So suppose any file content I want to see. So testing 123 slash test.txt. Okay. So far we have done this command. Okay. So mkdir, ls command, get put command, and get command. Okay. Now I want to merging the two file in my local and create a one single file in Hadoop. How I can do? For this testing, I should have two local files. Okay, so you can see two local files. So you can say cat test1.txt and test.txt. So you are getting the both files content. The first one is but both are same. Okay, so I just merge it. Okay, what I will do, I will do Hadoop fs minus append to file. Okay, append to file and two local file I have to get test.txt and test1.txt. Even more than one also you can. But after that, okay, after that the one path will be the Hadoop path. The final path will be the Hadoop path. Hadoop path will be testing123 slash. I want to create a new file with test2 name. Okay. Now I want to verify in this test2.txt what it came. Okay. So Hadoop fs minus cat command. Then we say testing123 slash dot. See the two lines, right, in the individual files are concatenated, append to file, right? Appended. Okay. And then you got a one single file as the test2. This command is append to file. So similar reverse version of this command is get merge command. So the another command is a get merge command, Hadoop fs minus get merge. Okay, it's a single like a get and merge together is okay, there is no capital. And the first get merge is a reverse of the append to file. Here local two files and creating a one Hadoop file. And now here is two Hadoop file and creating a one local file. So like I say, I have testing123 having two files, right? So one is testing123 test.txt is there, and one testing123 slash test2.txt is there. So in my last step I created, right? So I will be having both test.txt, and I told you Hadoop path you have to give complete path, and then you give your local file. The local file I want to save with test.txt. Okay. Now I will run this command, this get merge. So I have to see in my local cat test.txt. The total 4, 3. Oh, okay. So there is a one file is having one line and other file is test2.txt, which I copied in the last step. This one has two lines. So if I see Hadoop fs minus cat testing123 slash test.txt, how many lines are there? One. And test2.txt has two lines. So total how many lines you will get in the local? 3 lines. So this is just a concatenating file, right? This is the utilities, right? Like you can merging the files, right? How to copy the file after merging as a single file. So these are the use cases, right? When you so if Hadoop fs you do, so here we covered get merge command and append to file command, get command we use. Okay. These are the some permission commands are there, ch group, ch mode, ch on. Okay, one concat command is there. Copy from local, copy to local. Count command is very simple. Any directory you give count, it will give the number of file and directory in that. Hadoop fs minus count. So it is telling about one directory, two files, like this is total. So if you see Hadoop fs minus so this minus R command is like any directory is there, then it will show the directory. Okay, we right now directory is not there. So I create a one directory inside testing. Oh, yeah. I create another directory inside this test 234. 234 I created. Now if I do this command, ls minus r command, or I'm doing the outer root directory. So you can see if you don't use the minus r recursively, so what it will do? Only testing 1, 2, 3 it will show like what are the files and directories. But it is showing here testing 1, 2, 3, 4 directory. Suppose any file is there in the testing 1, 2, 3, 4 also, that it will show also. Okay. Suppose I copy some file. So test 3.3 testing 1, 2, 3 testing. So here, if you do, this is yeah, I'll check this command. Actually, one command is which can show every. See, that is Linux also we have, right? Three kind of structures. It will show every directories, files, the complete tree structure. So in the
I think you need to install that. Install tree.
tree is a,
Sometimes
so that is a Linux one, but in the I'm saying in the
the Ubuntu you need to install it.
but that tree is basically Unix one. But I'm saying in the when I'm doing Hadoop fs minus ls with ls command, we can use one option basically that will show like how can you see directory inside directories.
Yeah,
Okay,
that is what it's a package. You need to install that package, tree package.
tree, but tree is not Hadoop command, right? Tree is actually there is a one I will show you. Okay.
Oh, okay.
There is minus r capital. That's
Okay.
you've seen that now, ls minus r capital. The ls minus r slash. Okay. So like different directories is showing now. Now let's see. Okay. Actually, I use small r. Actually, difference is okay. I use a small r. That is recursive purpose, right? Just only generally use in the rm command and okay, for that purpose we use. But when
Okay.
you want to see directory inside directory, so you don't need to give the second directory. Because second directory you give, it will check in the second directory all the directories and the files. Okay. See, tree you are saying that is particular Unix and that need to be installed. That is a utility. Okay.
Yeah.
But here that tree we cannot use here. See, now it's coming like testing 1, 2, 3, test.txt, testing 1, 2, 3, test2.txt, testing 1, 2, 3, test 2, 3, 4 directory, and testing 1, 2, 3, test 2, 3, 4, and test 3 test. So all the files and directories are coming, right?
Yes.
Correct. So this is the minus R. So you don't need to go each and every directory and see the ls, right? So in a one single command, you can see all the recursive, all the nested, not recursive, nested directory structure you can see. Okay. So nested directory structure you can see by using -R, capital R. So -R is not giving error, but it is not showing anything.
What if we don't give the working directory, like testing 1, 2, 3? Does it show all the?
Oh, okay. So you don't give it like root you give. So at least you have, if you even don't give this anything, okay, I'll show you. That is a base directory. Okay. So if you have something in the base directory, like I have not created any folder in the base directory directly without slash. Okay. So if you
Okay,
so
it shows up
this is
all
my base directory.
directories.
So this base directory, if you don't give any slash, that is a base, right? Okay, not root. Okay, okay, this is a base directory. Okay, without slash. This is all created without slash. Okay, and when you give only slash, like we give only slash. Okay, so this is the root, and any directory you are creating like slash test, slash testing 1, 2, 3, all will come to inside this root. Okay. Okay. So here,
Thanks, Arvind.
like it will be coming very big, right? Because I have lot many directories, files, directory inside directory. See, this will be traversing your entire root, right?
Yeah.
Nested, with nested everything. Okay, I told you it will be big, right? Because too many files, too many directories are there.
Just hit cancel.
So if you don't give slash, means that is your base, right? Without slash. So even without slash, you also can give, or you can give slash. So slash you give, that will become in the slash field. Okay. Okay, practice this command. Okay, tomorrow I will cover the other commands. Okay, so the other commands are all other Hadoop express, like permission commands are there, chmod, chon, chgroup. If you know in the Linux that command, so you can
Yeah.
understand here, right? Because the command purpose is the same here, like
Yeah.
chmod, changing the group, changing the owner, changing the permission, like chmod permission is there, like 777, 754, like those permissions, truncate command, touch command. Okay. Okay. So tomorrow I cover, and meanwhile I'll give you the list of all this command, so you can do practice. Okay.
Okay.
So the command will take -R, capital, and then you take testing 1, 2, 3. Okay. Okay. I'll just post this all. Okay. So you can go and practice. Okay.
Okay. Thank you, Arvind.
Thank you.
Thank you, Arvind.